Okay, this is a recording for chapter 4, Graphing Techniques, question number 7, parametric graphs. So a curve is defined parametrically by the equations as follows. Find the axial intercepts. Alright, so what does it mean to find the axial intercepts? Okay, is to equate x equals to 0, solve for y, as well as y equals to 0, and solve for x. Alright, so recall parametric, the difference between Cartesian and parametric is that for Cartesian, okay, if you are given x, you can find y, and vice versa. But for parametric, okay, given x, you actually have to solve for t first, okay, the parameter, before you can get to y, and vice versa. Okay, so first, I set x equals to 0, I solve for t. Okay, so when x equals to 0, t squared equals to 0, which means t is equals to 0. And when t equals to 0, you can see y is equals to 1. Alright, that's why I have the very first axial intercepts. Okay, the y-intercept. Next. Now, when y equals to 0, you realize it's impossible. Okay, it's impossible to solve for t, right? Because this would mean that t4 is equals to -1, but there are no solutions since t, the power of 4, is always a positive number. Okay, so that is the reason why the solution, okay, says that, okay, the solution says that x is undefined. Okay, so there are no x-intercepts. Alright, okay, so next we are asked to look at the asymptotes. Alright, so asymptotes actually, we are looking at the behavior as x or y goes to infinity. Now perhaps I offer you a easier way of seeing this compared to the solution. Okay, is the fact that you can observe the Cartesian equation from here. Alright, so can you all see that I can rewrite y as the square root of t squared power 2 plus 1. This will mean that this is actually the square root of x squared plus 1. Okay, so alright, so in fact you can pull out the argument, okay, that as x goes to infinity, okay, 1 is negligible, right? So y will approach the square root of x squared. Okay, and the square root of x squared is actually equals to the modulus of x, not just x. Okay, so alternatively, you can follow the solution here. Okay, as t approaches plus minus infinity, y approaches square root t4. Okay, which actually is equals to the modulus of t square, but the modulus of t square is just t square because t square is always a positive number. Okay, so we have an oblique asymptote, okay, of y equals to x. Okay, the graph is as follows, but I'll just show you how to key this into the GC. Okay, please pay attention to this, especially for parametric graphs. All right, the range of values of the parameter is very important. So on the GC, okay, go to mode first, change it to parametric, go to Y. Okay, so I have many things here. Here's the first one. So let's key in accordingly. X equals to t squared, and y is equals to the square root of t power 4 plus 1. Okay, don't be so eager to press graph. All right, don't be so eager to press graph. Hold on, let me just delete this too. Okay, so don't be so eager to press graph. Change your window. See the window? The range of values of the parameter is now 0. I don't know what's on yours. Okay, but we are supposed to include all real numbers. So perhaps maybe I just choose a random number, just between negative 10 to 10, just to make sure that I have a range. I have the positive as well as the negative values of the parameter. Sketch the graph. Okay, and you can see it's a curved shape going this way. All right, of course, we have already found out what is the what you call that, the oblique asymptote. Okay, so in fact, I'm going to show you. I can also draw the oblique asymptote. Actually, it's very simple. Okay, this is just additional. Actually, I can just put y2 equals to t. So can you see actually if x is t, y is t, is just the Cartesian equation y equals to x, which is our oblique asymptote. So let's see. All right. So in your lecture, some of your lecturers have already said, right? If you draw you should actually draw the oblique asymptote to see that, oh, your oblique asymptote is actually the correct one. Okay. So, yep, this is the final graph. So in your work, please ensure, okay, if I were you, okay, I'll make it a good habit to indicate that this is 0, 1. Okay, make sure you label, okay, and your graph, according to standards, should be approaching the asymptote. So make sure the gap here is not too large. All right. Okay. So that's all for this question. Thank you.